Hitchcock, so not the beautiful one. But anyway, it's a lovely thing. I'm excited to be here today, to really talk about a lot of the work that I've been doing lately, thinking about education and thinking about how instructors can better serve our students, but all of our students, right? Not just the average student or the highest performing student, not just our whitest, richest student, but everybody. So we're really going to be talking a lot about educational inequities and what we can do to disrupt them. Just a moment. I think I'm probably not close enough to Zoom anyways. Okay, so this is a quintessential educational inequity. Actually, these data are coming from the state of California, but it's the same kind of no matter what state you look at, actually even no matter what country you look at. So what we're seeing here on the x-axis is two different subject areas, English language arts on the left, math on the right, and in three different grade levels. I've used my pointer a little bit. So I'll use it in a second. So we're looking at 3rd grade, 8th grade, 11th grade in English language arts and math. And then on the y-axis, what we're looking at is the percentage of students who are meeting or exceeding the state standards in this grade level subject and subject area combination. But the data are disaggregated by student family income level. So in dark blue are students from low income families, and in light blue are students from high income. And you can see across grade levels and across content areas, students from low income families, low income backgrounds are less likely to meet or exceed standards relative in comparison to their high income peers. So this is a quintessential educational inequity. Another way to look at similar data is this. So these are international data coming from PISA. It's a test that is administered internationally to assess what students know and are able to do. And here on the y-axis, we're just looking at the science score for these students. And on the x-axis, we're looking at a student, basically the circumstances of a student's birth. So their economic, social, or cultural status, also in really assessed from PISA. And you can see here that there's a positive correlation between the circumstances of one's birth and their science score. Anytime there is this association, that is inequitable and is an inequity. And so I'm really trying to think about, and my research program is really trying to think about what instructors can do to disrupt some of these inequities that manifest in our class. So before we get too far, I definitely want to make sure that we're on the same page in terms of terminology. So most of the talk, I'll be talking about inequities in student outcomes. So either course grade or graduation rate or retention, something like this. But there's also, of course, tons of inequities in the student's experience in the classroom as well. Historically, these inequities have been called the achievement gap or opportunity gaps or an attainment gap. In education, there has been a relatively rapid move away from these terms, actually. And in my mind, as somebody who really cares a ton about data and is very compelled by data, this Quinn paper it really clearly demonstrates that when we use achievement gap discourse, it imbues a deficit mindset in the listener. And so these data show that when we use achievement gap discourse, people are likely to to think Black students are way lower achieving than they actually are. And so I have moved away from this discourse almost completely, but it's been rapid. And so many papers, you'll still read lots of papers that say achievement gap or opportunity gap or attainment gap. And of course, there's inequities in experience. I'm not going to talk too much about that, but some of the work that I'm doing right now is really thinking about that. And so I'll tell you a little bit about that. And I'm totally happy to answer questions anytime. Also, if you have a question as we're going along, feel free to interrupt. Oh, good, first hand, yeah, totally, yeah, okay. You're okay.
What would you recommend we use instead of achievement gap?
Yeah, that's a really good question. Yeah, right, like what do we do if we're abandoning a term, what should we do instead? I try to be pretty specific about what we're talking talking about. So for me, I use inequity in course GPA, or inequity in retention or graduation rate, something like that. I think, yeah, I think, so that is kind of one way to do it. I think the other thing that we as an education field are working towards and need to do more is really centering the voice of our minoritized students in a way that like historically we haven't done, right? Like anytime we have a comparison, like we're holding one group to the so for me, also I'll use inequity. It's a really good question. A really good question, and for sure a work in progress. Kind of always. And also it's a nice next point I was gonna make too, is that kind of no matter what we call what we're about to look at, it's really important to remember that the inequities that we observe in our classrooms are because of the context, not because of our students, right? And so said another way, we need to fix our institutions, not our students. Like it's not, something isn't wrong with the students in our classroom. Something is wrong with our classrooms. So it's really, oh yeah, there's four big reasons, at least four big reasons why we need to disrupt educational inequities, particularly in higher education, in my opinion. So one is that completing a four-year degree is the biggest driver of income inequality in this country, certainly. So these data are coming from the Pell Institute. We're looking at year on the x-axis from 1970 to 2018. And the proportion of students who have graduated with a four-year degree, but the data are disaggregated again by family income. And so you can see that our highest income students from the highest income backgrounds are graduating from four-year institutions at a much higher rate than students from all other income levels. And so this is a huge problem, and kind of thought of a different way. If it's true that completing a four-year degree is the biggest driver in income inequality, higher education is exacerbating the problem, not ameliorating it. Right? And so we need to do something about this problem. The second big reason, right, of course, is that we can't meet the STEM demand, the STEM workforce demand, if we're systematically excluding some people from this workforce. So this is part of the motivation for the PCAST report that President Obama received, and why he said we need 1 million more STEM graduates by now. We have not met that goal, and we will continue to not meet that goal if we don't allow all students to access these degrees. Third, of course, right, we're in a time and in a world where we are facing increasingly complex problems. And if we're systematically excluding some voices from the table, we won't be able to solve these problems well or efficiently. And then for me, what I think is actually the most compelling reason of all of these is actually we have a moral obligation. We have a moral obligation to all people in our classroom and all people in this world. And so we need to serve all of them. So it's easy to look at these data and think, oh, wow, K-12, huge problems, right? This is a them problem, not an us problem. Like, look at those inequities. Please, yeah. Yeah. Yeah.
One is that low income scores lower.
Yeah.
But only half of 11th graders in the quote unquote best category still pass the test.
Yeah.
So the inequity issue is really a secondary problem.
Sure.
The first problem is only half the people who are not.
Sure. Yeah. How you rank those problems, I think it's reasonable people can debate about, but for sure I agree with you. There's at least two problems with these patterns. Yeah, exactly. Yep. Yeah, we need to teach better. Everybody. Yeah. Good. Okay, super. So it's easy to look at those data and think, oh, that's a K-12 problem. But I'm here to say, actually, that this is an us problem also. These data come from the University of Washington. Actually, this is from the Gen Chem series. So what we're looking at is the difference in GPA between peer students and non-peer students. So peer students are persons who are excluded due to ethnicity and race. So these are Black students, Latinx students, Hawaiian, Pacific Islander, and Indigenous students. And on the left, the notch plot on the left is showing the raw disaggregated data. So just, so not controlling for prior academic performance like SAT score and high school GPA. On the right-hand notch plot is this inequity controlling for these two things. So some people say it's a more of an apples to apples comparison that tries to account for some of these inequities that we see prior to coming to college or university, which I totally agree with. I personally am now committed to looking at both of these sets of data, actually raw and data controlling for prior academic performance, because it's the raw data that students experience in our classes, right? Students are not fitting regression models in their head to think, oh, that person has a slightly higher GPA than, or high school GPA, slightly higher SAT score, right? Students receive a grade and they talk to their friends and look around. So it's important, to me, it's important that we address both of those issues. I think the other thing that is interesting to note is that the raw disaggregated difference in GPA in the first quarter of the Gen Chem series is almost half a standard deviation, but half a GPA point, but how the grades work in chemistry, it works out to be about a half a standard deviation also. And that is identical to the difference in math performance in 8th grade math between Black and white students. So this educational inequity is not changing from between 8th grade math and when we come here. Also, these kinds of inequities have huge impacts on students, both how they feel in class, but then also the choices that they make. So here I'll show you, they are actually course survival probabilities. So I trained as an ecologist, and so I borrow many methods from ecology. I also right, as a plant ecologist, when I say survival, I mean something very different than when students use the word survival. But yet we use survival, and students will say, oh my gosh, I survived Gen Chem. So I feel comfortable calling this survival here, even though I'm actually not super comfortable with it. So what we're looking at here on the x-axis in both plots is the 6-course chemistry series, three quarters of Gen Chem, 3/4 of OChem, and the course survival probability. On the left is the raw survival probability, and then on the right is the survival probability controlling for SAT score and high school GPA. And I'll show you the disaggregated data. So first, if we're looking at non-peer students, so these are students who identify as white and Asian, we see some attrition through the series. This is not surprising for anybody who's ever been in a classroom, right? Not everybody moves on through the series. This is not surprising. You know how steep that line is, maybe is something that we should also think about. But this is what this line looks like for non-peer students. The problem is this, that for peer students, so again, these are students who are ethnically and racially minoritized in STEM, the line is both lower and steeper. And so what this means is that peer students are both less likely to move on to the next course, and it gets disproportionately worse for these students over time. And this pattern is the same whether we're disaggregating the data, or sorry, controlling for high school GPA and SAT score or not. So these kinds of educational inequities that we experience, that we see in classrooms, have huge consequences on students as they move through our majors or move through our university. Also, I should say, right, I've actually never seen a group of faculty move so fast when they saw data from classrooms as our colleagues in chemistry. So basically, immediately they saw these data, they formed a chemistry education research group. Super jealous, they call themselves Cheddar. That's a good name. That's a really good name. And they all, many of them started thinking about ways they can innovate in their class, data that they can collect to see if those innovations have impacts. It's really a remarkable feat that they have accomplished. So I think about all of this, and knowing that we need to fix our institutions, I think about what I can do in my classroom. And specifically, then I think about if maybe active learning is a solution to some of these problems that we have seen. So active learning, right, can mean a lot of different things to a lot of different people. It has become kind of this catch-all phrase. For me, the things that make active learning active are, first, that it engages. These are pedagogical techniques that engage students in the learning process, in the construction of their own knowledge. Two, it's activities or discussions as opposed to just listening to an expert speak. Even single students asking questions, it doesn't quite get active to me. And also, active learning often hinges on higher order thinking, right? If students are actually constructing knowledge together, they can get to higher level thinking. In my classroom, certainly, but also in the literature, active learning often hinges on some form of group work, whether it's informal groups like turning to your neighbor and discussing something, or formal groups where students work together for longer periods of time. So for the rest of this research talk, I really have three driving questions. So one is, if active learning is going to be effective at disrupting educational inequities, we need to demonstrate that it's effective across contexts. So is it? Next, can active learning promote equity and disrupt some of the patterns that we're seeing regularly? And then third, what are the classroom implications of this? As an instructor, what do I do? So with that, let's get into the data. So to answer this first question, we conducted a meta-analysis of STEM learning classrooms. This was a huge group of people headed up by Scott Freeman, actually, and we had almost 30 undergraduate, graduate, and postdoctoral coders who coded these papers after the systematic review. And in a lot of ways, I think of this paper as an update to the Freeman 2014 paper. And I will say, if there's one paper worth knowing about in the active learning literature, it's probably this Freeman paper. It's been cited, even just in the last 10 years, it's been cited thousands of times. And so the Freeman paper, coded papers from 1998 to 2010, they had a total of 158 studies. We picked up where they left off, so 2010 to 2016, we have 133 studies or 232 case studies. Our methods are slightly different, like how we're dealing with studies that contribute multiple data from multiple sections of classrooms. And so I'll be talking about case studies more, but you can think of those as a section in a classroom for the most part. Also in our paper, we really tried to get deeper into active learning. Like, what is it about active learning that's effective, right? The Freeman paper really just tried to show active learning is effective, and we're trying to dig into what is it about. So are there different types of active learning that are more effective? Active learning intensity, so how much time we're actually asking students to work together, and a number of other characteristics. So I'm going to show you data on these different things. So the type, class size, course level, introductory courses, and upper division courses, subject area, they're all STEM classes. Yeah, they're all STEM classes, and the amount of time that students are working actively. I'm going to leave this here for a second, get a drink of water, but you think about what differences do you think we're likely to see if we're comparing active learning classes to passive lecturing classes? Okay, so I'm only going to show you data from exam scores. So to be admitted into their study, a couple things had to be true. The authors had to use identical exams in an active learning class and a passive learning class. The instructor needed to be the same. The class, of course, needed to be the same. I think that's it. Actually, I'm trying to remember. And I'm going to show you the effect that we see. These effects you can think of as the effect of active learning. So they're measured in Hedges G. The units are standard deviations. I will build out this graph on the left. So again, you can think of the effect size as the effect of active learning. If the effect size is 0, that means exam scores in passive learning classes and active learning classes were the same. If the effect size is negative, that means that exam scores on these identical exams were lower in active learning classes than in passive lecturing classes. If the effect size is positive, the exam score was higher in active learning than passive learning. I will also give you a number next to the title of what the row is, and that number is the number of case studies that informs that single data point. So in overall, we have 230, we have 232 case studies in this study, but not all of them have all of these combinations. So overall, we see that the effect size of active learning is about half a standard deviation. And so what this means is that students in an active learning class score half a standard deviation higher on average than students on this identical exam than students in a passive learning class. And then we'll build out this to cover a couple of different categories with a couple of different levels within each. So first, if we think about active learning type, the studies that we included covered a bunch of different types of active learning. So clickers or flipped classrooms, collaborative groups. There was a pretty big bucket of classes or of studies that had a combination of methods. And then we'll look at data from class sizes. So a large class, medium class, small class. So we did not, there were a few classes that I would call mega classes. So I'm teaching Bio 180 this quarter. I have 597 students. So that is squarely into the large class. These class sizes came partly from the Freeman paper also, just to keep methods consistent. And so what we see is this. So again, this studio classrooms with only 7 sections, that open circle means that the effect size is not actually statistically significantly different than 0. But for all of the other active learning types, and regardless of class size, students in active learning classes score higher on identical exams than students in passive learning classes. Maybe I'll pause and yes, and answer questions. Yeah,
So with the clickers, do you know if that is course where you get graded if you show up to take a clicker versus?
Yeah, well, good question. Yeah, so So some instructors grade clickers, some for participation, some for accuracy, and some for nothing. There is a mix in that. Yeah.
But I guess I'm wondering if the clicker effect is actually a way to get people in class.
Yes, totally. Yeah. Oh,
So
yes.
They know it's not graded in front.
Yeah, exactly. They know it's not graded, they probably won't show up. I think even, so those studies are still in this sample. And so even if there aren't any points associated with clickers at all, participation or graded, they're still in this. Yeah. The other thing that's a little bit awkward, and that I think probably partially explains the large error around that clicker estimate is that lots of different people use clickers in different ways, right? Like there were some studies for sure that were like, yeah, I had one clicker question a day. That was my active learning, right? And that's just not a lot in comparison to what some other studies were like, yeah, we use somewhere between 5 and 15 questions. And so that probably is. There's also something coming up that will also help. Yeah, it's a good question. Any other questions? Oh my gosh. Okay, you first.
I was curious, like, do you know what order they were taught? Like, they do the traditional and then the active learning, or they do the same order?
Yeah, that's a good question. So sometimes they taught it in the same order. It kind of varied by study. Some taught it in the same order, like section A would be active learning, section B would be traditional lecturing. We did not admit ones that, like, it had to be basically by class. The treatment had to be administered by section, not by unit. Does that make sense? So like it couldn't be like super active learning for this 2 weeks and then super passive learning for the second 2 weeks, and that it needs to be the whole class. Yeah, so that was one. Most often it was active learning by quarter, right? So like active learning 1 quarter, passive learning the next quarter. Occasionally by year, right? Just how like a lot of university like course scheduled work, like maybe the same, I almost called it the same sucker. I don't mean that. The same person probably doing over and over and over.
right? Yeah, so it was a little bit of a mix. I would say, we didn't actually look at this, but I would say that most were transitions from passive learning to active learning. Yeah, and there's, there's also for sure gonna be a bias in this, right? Like, not any old person is gonna make this transition and then publish about it. And so there is a bias. That's a little bit, that's hard to assess, although we had, in meta-analyses, you can like assess for some of the publication sampling bias, but not necessarily the participation. Does that make sense? Good, thanks. Okay, and then Jose, I saw your hand too, but go ahead. Either. I will not choose. Yeah,
I was about to ask you these. Do you use clickers in your
I do use clickers.
You get points for participation,
Participation, not for accuracy. Yep.
and that's how you grade.
Yeah, yeah, I usually, so we have anywhere between, like, one day we had 11 clicker questions, and then, 1 year maybe even, and then like on the mid-quarter evaluation, students were like, too many clicker questions. And so I've scaled back for sure, but it's usually more like 5-ish, 3 to 5, I would say. But each day of polling is worth 2 points in my class. And so then if students answer half of, if it's a day that we have 10 clicker questions, they only answer 5, then they get 1 point, right? But if it's a day that we have 4 questions, right? It's like, yeah. Very
I'm just curious about the difference between collaborative groups and problem-based learning.
Yeah.
Because I can imagine that there's massive overlap between the two.
There's a huge amount of overlap. Yeah, thanks for saying that. Yeah, so collaborative groups, we said basically any kind of formal group work was collaborative. We did not include fair share in collaborative groups. It had more formal than that. And so problem-based learning is like a thing in the literature, right? So purists would say that like problem-based learning or case studies or project-based learning, right? They're all different things. And we try to stay true to that a little bit, but I agree with you completely that there's probably a huge amount of overlap between problem-based learning and collaborative groups. And we tried to stick with what the authors of the original. Yes. Oh, yeah, Chris.
Yeah. Hey, I'm not sure if this might have been constrained by a sample size, but I'm curious if you broke down each of these active learning types by class size as well.
Yeah,
I'm curious if like some are more effective in large classes, but not effective in small classes, and vice versa.
Yeah. What a good question. No, is the short answer. We did not do that, but I think it would be super interesting to do. I am a little bit worried about sample size with some of, like, certainly with some of these, especially active learning type. Yeah. So we didn't, but every single time I talk about this paper, so that tells me I'm sure we probably should. Yeah, I think it's a good question, and just make some rules for ourselves about it. It's a really good question. I want to show you more data because I'm actually more excited about this next one. So this is so we're looking at intro and upper division at the very top, subject area. I'm so sorry that picture is. Sample size. Anyways. So and then active learning intensity. So with each of these papers, we try to determine how much time students are actually working with each other versus listening to the instructor. And so this could be accomplished, and we have, one giant bin of unknowns because it was really hard to tell from the paper, exactly, hard to quantify from the paper, because exactly 0 papers said, learning intensity was 50%, like nobody said that. And so instead, what we tried to do in these 3 bins, we binned papers, and so a high intensity active learning class would be a class where students spend 66% of the time or more working together in groups. And you could accomplish this in a couple of different ways. It could be, right, in a 60-minute class period, you spend 50 minutes of that class period all working together every day, right? Or it could be, if your class only meets 3 days per week, it could be 2 of those days are super intensely active, and then the 3rd day is just 3 days.
right? There's a couple of different ways to do that, to get at the same thing. And so we grouped papers into high intensity active learning, medium intensity, and low intensity. And we found this, that high intensity active learning classes and medium intensity active learning classes were more effective than low intensity active. And in fact, classes, right, low intensity active learning classes where students are only working together for a third of the time or less, the performance on these identical exams was the same, statistically the same in these classes compared to passive lecturing. Are there questions about this? Yeah, thanks. Yeah.
I'm curious to know, if, like, there's a way to measure the total amount of like time with these things. I would imagine that with active learning, you could be spending just like more time doing material.
Yeah.
If you do lecture, but ahead of time, you then do the exercise, just the lecture in class.
Yeah. What a great question. Okay, so there's two things come to mind. So one is there's this really amazing tool called DART that is I believe it's a phone app actually, and it measures the decibel level in the class, and then it can sort. Oh, this is a single voice talking versus a bunch of voices talking, and so it's a super cool way to get a ton of basically binary data from your class. I don't actually think that was what you were asking about, but when you first started talking. So the interesting thing, so to be admitted to the study, the course structure had to be the same. So they had to meet, the class still had to meet 3 minutes, not 3 minutes, 3 times per week for 50 minutes. And so in that way, we're like controlling for the amount of time in class. I love your question though, because the question I usually get is in like the opposite way. So I'm gonna use, I just love the way you think about it. The question I usually get is like, whoa. If I start doing active learning, I need to cut content, right? Because in a lecture, it doesn't matter. Like the instructor doesn't know how much the students are learning, right? They're just going along and like saying their thing. Right, and so I think you're exactly right, that in the active learning classes, right, you're probably not covering as much, frankly, but students are learning way more. Does that make sense? So I think you're right, and I don't think it's a problem. But reasonable people can disagree, and I feel,
Does the textbook become more important when you're spending a lot of time with student interaction?
This is so fun. Like the short answer is probably, so in my class for sure, which is like another, I worked on another project thinking about textbooks. Oh, and it was ugly. Yes. So in my class, I assign readings to students. You have to read X number of pages, answer these very low level multiple choice questions. Anyways, and answer these questions. And so yeah, for my class, students do rely on the textbook to a certain degree, but then when they get to class, we can move beyond the lower level content, right? Like we don't talk about definitions very often, right? We're talking about how we apply these concepts that we've read about into the real world or into scientific, into the science of it. Does that make sense?
Well, I'm just wondering if the students don't understand something in the textbook,
Yeah.
or they misunderstand it, then the class interaction is an opportunity for them to get straightened out.
Oh, yeah, totally.
How does that information get to them in the first place if very little of the class time is the instructor giving information?
Oh, yeah. So for me, I know how much students are learning when they respond to my questions, when you can actually even hear the change in the volume from when like they're really working on something to then when they're talking about something different. And if that change happens too fast, it's either because they have no idea what I'm talking about, right? Or it's because the question I asked was like way too easy. And then I can look at the question and think, oh yeah, that's an easy one. This transition is gonna happen too fast. right? Or if it happens too fast, like this is actually a hard question, so I wish that happened. So that was one way. Also with the clicker, right? When they pull in on the clicker question, if it's a flat distribution across the answer options, right? Or if it's like the opposite of what most people are selecting the wrong answers. Which, yeah, that, happened yesterday. It's fine, it's okay, yeah, it's an opportunity. Yeah, Keegan, thanks.
Ever taken into consideration like semester the court system?
Yeah, what a great question. No, we didn't. These data have all of that wrapped up in like as quarter system and semester system. I suspect that the quarter system is underrepresented in these data actually because really quarter system is the minority in this country. Most schools are on the semester system. Yeah, it's a good question. There was also these data are really coming from a range of institution types. Some are we have like maybe one or two community colleges that in the sample, but we took them out of this. Yeah, good question. Yeah.
Yeah, I'm just curious, is this all US universities or is this?
Yeah, good question. So for sure the papers were in English, and so there's going to be a US university files there. But no, there were some universities. I know we had a couple of papers from Turkey and a couple of papers from England. Yeah, but it's super majority. Okay, you ready for what's next? Me too, I'm excited. Okay, so I look at these data together and think, yeah, okay, there's lots of different types of active learning that are effective. It's effective really in any course level, any class size, and any subject area. And that low intensity active learning is really not much better than straight lecturing. So, but the question why that really gets me excited is about thinking about if active learning can promote equity. So to answer this question, we did what they call an individual participant data meta-analysis. And so what this is the same thing. We use the same studies that we had systematically reviewed from the literature, and then asked all of those individuals for their raw data. And so what this, like in a lot of ways, this is considered the gold standard in meta-analyses because you don't have to make any assumptions about how, or you can model empirically the clustering that happens among your data points, your students in classrooms and in studies with instructors. And so to do this, we contacted every author from both the Freeman meta-analysis and our meta-analysis, a total of 291 studies. And we asked the authors for their raw disaggregated data that compared passive learning classes to active learning classes. In this case, we have we asked for both exam scores and also the probability of passing the class. And we wanted the data disaggregated by student, race, ethnicity, or family income. So again, two different outcomes that we were looking at. And we got what feels like a fairly comfortable response from a statistical standpoint. I'm really happy with it. 15 studies contributed data for almost 10,000 students in 51 class sections for exam scores. 26 studies had data on passing rates for almost 45,000 students in 170 different sections. Yeah, thanks.
In looking at the factors that you looked at, does anybody look at how many hours the students are working?
Oh, yeah, good question. Yeah, totally good question. Yeah, they're only, students are only in your class for 15 minutes a day, tops, right? What about the other 23 hours?
I mean, certainly with family income, I would think that whether the students are working 20 hours a week or 40 hours a week, or not at all,
yeah,
is going to have an impact.
It's going to have a huge impact. Yeah, it is. So we didn't look at that in this study. Yeah, we didn't look at that in this study, but there are tons of studies. There's actually a really interesting study that extended that analysis to look at the amount of time students are spending working. Basically, some of our colleagues in community colleges or regional schools were like, no, I can't possibly do active learning. Expect my students to read the textbook. They're working too much. And so somebody set out, I know, yeah, exactly. And so some folks set out to test that hypothesis at a bunch of different community colleges in 2 regions of the country. Community college regionals and R1s. And they actually found the opposite, that students who work more tend to also work more on the class. And students in community colleges, same thing, work the same or more than comparable students than students in the other university types. Yeah, it's a good question. Okay, so disaggregated data is, so in total, right, we have almost 54,000 students in this data set from 37 total studies. This feels really good to me, from a statistical standpoint. However, it's notable that fewer than 14% of studies that we contacted contributed data to this, and the super vast majority of the reason why folks didn't is they said they didn't disaggregate their data. And that is a huge problem. Our university falls into this trap as well. No, this is recorded. Maybe I should. It's hard to disaggregate our data, but if we don't, we are only measuring the majority, right, by definition. And so I have committed to never talking about this paper without naming this as a huge problem. We have to disaggregate our data. It has to be part of our regular practice. So despite feeling comfortable with the overall sample size, we did something that I feel a little bit uncomfortable with. So because these different studies disaggregated by slightly different metrics, whether it's race or ethnicity or family income, we ended up combining students into a group that we called students who are minoritized in STEM. And this is a problem. Statistically, there's precedent for this in the literature, and there are some ways that this makes sense. But it also erases some really important variation about the student experience in our classes, right? A high income Black student is going to have a different experience, both qualitatively, maybe even quantitatively, than a low income white student. And I think, I hope that when somebody does a follow-up on this study in 1 year, 10 years, 5, whatever, we don't have to disaggregate, we don't have to lump students in this way. We can better disaggregate by individual identities. So with all of these data, I fit hierarchical Bayesian regression models to understand some of the patterns here. Happy to talk about this. This is like, with this audience in particular, I'm super excited about that, but I'm just gonna leave that there for now and expect questions or hope for questions. Okay, so again, we're trying to answer this question: can active learning promote equity? I'm going to show you data that looks like this. 2 panels. On the left is exam scores. On the right is the probability of passing the class. Oh yeah, and these are the inequities that we see. So the difference in exam score for minoritized students in STEM and majoritized students in STEM. The 0 line would indicate that there's no inequity between these 2 different groups in exam scores or the probability of passing the class. And on the x-axis, we're looking at treatment. So again, this is comparing passive learning or straight lecturing to active learning. And so what we see is this is actually notable in my opinion, because this is that half a standard deviation. Again, on average, students in universities across the nation score half a standard deviation lower. Minoritized students score half a standard deviation lower on their exam scores in passive learning classes compared to their majoritized peers. And so then if we look at all of the data together, it looks like this. So I look at this and see that active learning is better. The inequity is smaller in active learning classes than passive learning classes. And in fact, there's a 33% reduction in this inequity in exam scores and a 44% reduction in this inequity in the probability of passing the class. But of course, there's a ton of variation. So these histograms are showing you the change. Okay, this is a change in the difference when we're moving from active learning to passive, when we're moving from passive learning to active learning. And so again, exam scores on the right, percent probability of students who are passing the class I'm so sorry. You get it. I said the wrong thing. So on the right-hand side of this vertical line, these are classes that promoted equity with the move from passive learning to active learning. On the left-hand side, these are classes where the inequities actually got larger with this shift from passive learning to active learning. And really, I deeply want to know why, like what can explain any amount of this variation. So we collected some data to understand this, and this is kind of the heart of the next project that I'm working on. So active learning intensity, it turned out, was a big predictor in whether or not in the inequities in a class. So we didn't have any studies that were categorized as medium intensity classes. So I'm only showing you low intensity and high intensity active learning classes. Exam scores on the left still, passing on the right. And so what we see is this, for the difference in exam scores, is that as intensity, like high intensity active learning classes have the smallest inequity compared to either passive learning or low intensity active learning classes. And the probability of passing was even more dramatic, where high intensity active learning classes had a 76% reduction in the probability of passing the class for minoritized students compared to their majoritized peers. So I actually planned to take questions here if there are any, or just like think about this for a second. Yeah, Chris, thanks.
Just for explaining some of that variation you saw, I'm curious if you have any data that was the student's first time interacting with active learning.
Oh, yeah, what do you
experienced before?
Yeah, what about, no, no, don't have any data. Yeah, but that's a really good question. Yeah, I feel that actually acutely in Bio 80, as the first class that most students are taking in the biology department, right? I'll talk to my colleagues who are teaching, Bio 200, this is a 3-course introductory series. And they're like, oh yeah, these students know how to do like whatever. And I'm like, yes, as we practice it so much. In biology, yeah. Whereas like for a lot, it's new. This kind of learning is new and hard for students, often. And so, yeah, as the first course in the sequence, or for first fall, first year students, yeah, we don't have any of that data. It's a good question. Yeah, we did see upper division classes tend to have much smaller inequities than lower division classes. But the strong hypothesis there is because we're weeding students out, right? We're like, yeah, it's left by it. Good question. Anything else? Yeah, thanks.
Are these all in-person classes or are they online?
Oh, yeah. Yeah. Good question. So most of them were in person. There were a couple that were like part of their active learning was partially online, like moving from like a low structure in-person class to a higher structure partially online. Yeah, or they, students maybe interact with some of the content online, but then come to class and do something like that. There were a couple of studies in this sample, like that was very easy. Yeah, it's a good question. Okay. So a big hypothesis that we have for why, first of all, why high intensity active learning is so effective, but also that I am hoping will explain some of the other variation that we see in the efficacy of active learning, we call the heads and hearts hypothesis. And this hypothesis follows that an educational inequity affects a whole student, right? In theory, you're impacting a student's head because you're trying to measure what they know, but also like what students experience in the class, or what they like really deeply impacts their heart. And so if we want to disrupt these inequities, we need to activate both the head and the heart in students. And the idea is that this deliberate practice that's so prevalent in high intensity active learning is the way that we're activating students' heads. So high intensity active learning often is really focused on the challenges for students in what they're actually learning, but then is coupled with scaffolding, but also an instructor's pedagogical content knowledge, that knowledge that comes with, oh, I know this is hard for you, but also I know that this is going to help you learn that thing better. And it's right, high intensity active learning is often coupled with very immediate feedback, whether it's through clicker questions or through instructors circulating around the room, and the group work that students are doing, co-constructing knowledge together. But again, in order for this kind of deliberate practice to be
to increase equity. It needs to have a disproportionate benefit for students from minoritized groups. And this kind of active learning is not necessarily common in STEM. So for a lot of students, this might be the first experience they have in a science classroom with this kind of teaching. And so for a lot of students, it can be like a coaching experience that they have. And so it's repeated and targeted practice, really intentional feedback, and this idea of normalizing struggle, right? You are not alone in your learning. I, as an instructor, am here to help you, and your colleagues are helping you as well. But also, this kind of high intensity active learning really needs to be happening in a classroom that prioritizes the culture of inclusion. And this can be enhanced with instructor soft skills. So how we allow students to ask questions, how we respond to their questions, demonstrating to students that we care deeply about their success, but that success means high expectations, but structured support to ensure that students are able to meet those expectations, and having a care both for the student and the community that they're living in and working in. And again, this can have a disproportionate benefit for students from minoritized groups because it provides the psychosocial comfort that students need to take risks and then to learn. And it really promotes the sense of belonging and this notion that STEM is for everyone.
So that in mind, does diversity of the student body affect the effect size?
Yeah, what a good question. It doesn't. At least in the sample that we have, there was not a difference. There was not a significant difference between the efficacy of active learning and the population and the composition of the population of students. Yeah, at the same time, right, like there's plenty of other papers that say that it does matter. I think particularly for students who are solo in groups, right? And I think like the University of Washington is a very white school, white and Asian school. We're very, so again, like the student experience in our classrooms is gonna be palpably different than the student experience in a classroom that is not predominantly. Yeah, it's a good question.
We are way over time. I have more to say, of course, but we can also you tell me, we can, I know that, yeah, let me just keep going. You can leave if you want to, we can.
Maybe we can just hold the questions for now.
Sure.
Finish it, and then you take the discussion to the DGIT session.
Okay, cool. That's super fun. Okay, so this is really, we're setting out to test this hypothesis with Scott Freeman and a collaborator, Sarah Eddy, at the University of Minnesota, and of course the huge group of people who are working together. What we're doing is trying to collect new data from a bunch of different universities across the United States to really try to understand some of the variation in both the student experience in terms of the culture of inclusion in the classroom, but then also student outcomes. And the hope here is that we're able to identify elements of both that impact student learning in a meaningful way. And so these are the many of the things that we're looking at. So for example, I've highlighted competition here because the University of Washington is students have a palpable feeling of competition in our classrooms. And the hope is actually that we're able to fit a predictive model to these so that we can help instructors identify areas that they should improve now before it's too late for their students. So equity-minded instructors tend to disaggregate their data and look at student outcomes, et cetera, but that always happens at the end of the quarter, right, when those data are available, and it is too late for those students then. So we're hoping to fit this predictive model and pair that with a guidebook to help students, to help instructors know what they can do to impact students. I do want to end with classroom implications, actually, because the first time I showed these data to a friend and a colleague, she looked at this and she said, well, Ellie, this tells me if I'm not going to do high intensity active learning, I shouldn't even bother. I died a little bit inside that day. I don't think on my feet terribly well, and so I didn't have a great response. But now I would say that that's not actually at all the message I want to send. What I want to say is that as instructors, we need to keep going. It's almost impossible to transform a class from totally passive learning to totally active learning in one instantiation. I've seen it happen almost once, and it was, I highly recommend not attempting that, but to slowly change your course and keep going until you get to high intensity with small changes or some slightly larger changes along the way. And then of course, right, so you're fixing the institution in your classroom, but then don't stop there. We need to fix the institution outside of our classroom as well. All right, so that is the end. This is hugely, right, of course, hugely collaborative work. I'm really grateful to all the authors who contributed data also. And I'm happy to, yeah, hang around, ask questions. You can email me. You can stop by Hitchcock and find me on the 4th floor anytime. Thank you for having me.
Everyone will agree that it was an excellent seminar, but